Everyone knows NASA calls it just another interstellar comet, but the data tells a very different story. 3I/Atlas didn't drift into the solar system. It barreled in on a nearly perfect plane, with the planets tearing through at 58 kilometers per second. That's 130,000 miles per hour. Scientists estimate there's only a 0.2% chance this trajectory is random, and that's just the beginning. A Harvard professor now claims this object behaves unlike any natural rock we've ever observed. Consider the question: why would an outsider thread the solar system along a path that experts describe as a reconnaissance flyby? That's where the numbers start getting uncomfortable. Let me ask you something. When you hear 0.2% chance, does that feel random or deliberate? Tell us in the comments. Now, before we dive further, today's clues point towards something massive. So, make sure you're subscribed. You won't want to miss what we uncover next. Picture a comet drifting slowly across the sky, graceful, harmless. Now throw that image out the window. 3I/Atlas is not crawling in, it's blasting in. Unlike comets from our own Oort cloud, which remain bound to the sun and eventually return, this object is on a hyperbolic path, moving too fast for the sun's gravity to ever reel it back. Once it leaves, it's gone forever. This is the third confirmed interstellar object ever observed. First came Oumuamua in 2017, then Borisov in 2019. Each time, the story is the same. Sudden detection, a scramble to capture data, and the realization that we're watching a visitor from outside our solar system. 3I/Atlas was flagged as unbound the moment it was discovered on July 1st, 2025. Pre-discovery images show it was active months earlier, far past Jupiter. That's unusual in itself. Outgassing at distances where sunlight is barely a whisper is rare. But the real story is the speed. 58 km/s isn't just fast. It's a cosmic fingerprint of something born in another star system, wandering the void for eons and now crossing our path. And then there's the trajectory. 3I/Atlas didn't just enter the solar system randomly. Its orbital inclination is 175 dg, nearly flat, with the plane of the planets, moving retrograde against the usual flow. Most comets and asteroids come in at random angles. This alignment is extraordinary. Experts call it lottery-level improbable, a 0.2% chance. Why does that matter? Imagine trying to scan a model train set. The easiest way is to fly a drone directly above the tracks, aligned with the layout, so you can observe everything in one pass. That's exactly what 3I/Atlas's path achieves, but on a cosmic scale. The question isn't whether it's interstellar. We know it is. The question is, why is it here, and why is it moving the way it is? Because the numbers, the speed, the alignment, they all point to something far more intriguing than a random comet. That's exactly what 3I/Atlas is doing. Hugging the ecliptic, the invisible plane the planets ride on, but zipping past in the opposite direction. Astronomers call this kind of trajectory a grand tour, the same term NASA used in the Voyager days for missions plotted to hit multiple planets with a single flyby. You don't get that kind of alignment by accident. And yet, here it is, threading the solar system on a path that passes Venus, Mars, Earth, and even swings close to Jupiter. Each encounter aligned almost as if someone were checking boxes on a cosmic itinerary. Most interstellar objects should come in at steep angles, missing the ecliptic entirely. The solar system is a thin disk suspended in a vast sphere of space, and the odds of an outsider sliding in almost perfectly flat are vanishingly small. Yet, that's exactly what happened. Even the official discovery paperwork flagged the trajectory as unusual, not just for its speed, but for how neatly it lined up with the planets. An inclination of 175 degrees isn't just a number, it's a clue. Combine that with retrograde motion, and you start asking questions. Is this a cosmic tourist or a probe on a deliberate route? A 0.2% probability isn't a minor footnote, it's a warning flag. Now consider the comet itself. Picture the textbook image. A dirty snowball spinning through space, trailing a wispy tail. But physics tells us the jets from a comet's nucleus, made of frozen gas, dust, and rock, cannot shoot out in perfect, ruler-straight lines. The nucleus heats up as sunlight hits it, sublimating ice into gas that escapes along with dust, forming a glowing coma. Because the comet spins, These jets scatter in all directions, never perfectly aligned, and yet 3I/Atlas is moving as if it defies that chaos. Comet jets behave like a garden hose left running on a hot day. As the nucleus rotates, the streams of gas and dust sweep around, carving graceful spirals in the coma. Watch in slow motion, and you'd see arcs fanning outward, always curving away from the surface, never in a straight line. That's the rule. Even the most powerful jets, like those on Comet's Neowise or 67P/Churyumov-Gerasimenko, follow the same twisted, corkscrewing patterns. The tail itself obeys a script written by the sun. Solar wind and radiation pressure push the smallest particles away, so the tail always points roughly opposite the sun. Larger dust grains lag behind, forming a broad curved fan, but still, they follow the rules. The result is chaotic but predictable, a cosmic dance choreographed by sunlight, spin, and the laws of motion. Astronomers have spent decades modeling these jets, matching their twists and curves to the rotation of the nucleus and the strength of outgassing. Every ordinary comet, Halley, Neowise, Boris, Benton, tells the same story. Jets curve, tails bend, and the display obeys physics. That is the baseline, the standard expectation when a new comet appears. But 3I/Atlas? It ignores the rulebook. It's not just breaking the speed limit, it's breaking the geometry itself. Every comet we've studied spins, and that spin shapes the gas and dust it vents. Spinning objects create curved jets, no exceptions. Until now. With 3I/Atlas, everything we know about comet behavior gets turned on its head. The jets don't curve, they don't spiral, they don't wobble. Instead, astronomers are seeing something that should be impossible. Laser-straight beams of material, stretching over 1,000,000 kilometers, roughly 3 times the distance from Earth to the Moon. You could lay a ruler along them for 1,000 miles and never see a bend. The real shocker? The object is spinning, a full rotation every 16.16 hours, about 2/3 of a day. Yet these jets remain locked in place, pointing in fixed directions, completely ignoring the expected twist and curl. That's not just odd, it's physically impossible under natural comet physics. Here's why this matters. On a typical comet, as it spins, active surface spots rotate in and out of sunlight, firing jets that sweep around like the hands of a clock. Newton's laws and conservation of momentum dictate this behavior. But 3I/Atlas refuses to follow the script. It's as if the jets are aimed and held deliberately, a precision no natural process could produce. Let us know in the comments, did you already know about this comet? Or is it the first time you're hearing about it? Do you think this could impact the world? Or even your own life? Astronomers even gave this anomaly a nickname, 12. Not because it's merely strange, but because it breaks the chain of cause and effect every other comet obeys. Harvard scientist Avi Loeb didn't mince words. The straight jets could be a technosignature. Nature doesn't build straight lines on spinning bodies. Engineers do. Think about it. Every spacecraft we've sent relies on fixed thrusters or antennas to produce directed forces. So when a spinning interstellar object fires 1,000,000-kilometer straight jets, the obvious question arises: cosmic accident or deliberate engineering? It's a wild claim, but the images don't lie. The jets don't bend, don't spiral, don't respond to rotation. They just point. For the first time, serious scientists are whispering the unthinkable. We might not be alone. And that's not the only shock. NASA and ESA officially declared 3I/Atlas a dark comet. Its coma, the cloud of gas and dust surrounding the nucleus, stretches 348,000 km in all directions, nearly the distance from Earth to the Moon. But here's the kicker. It's dominated by carbon dioxide, not water vapor, not ammonia. This is a comet unlike any we've ever seen. They call it the smoking gun, the one clue that screams this thing wasn't born in our solar system, but in the deep freeze between the stars. Here's how the story goes. Yet here's an interstellar object on a hyperbolic orbit, skimming the boundary of Jupiter's gravitational reach with surgical precision, almost like it knew where the line was. Avi Loeb didn't dance around it. He called the pass an extraordinary coincidence, the kind of alignment you expect from a mission profile. Because if you wanted to drop a probe into Jupiter's gravitational well without burning fuel, this is the corridor you'd choose, and the numbers match, down to a fraction of a percent. Then we get our moment. December 19th, 2025. Its closest approach to Earth. Every major observatory is preparing. Hubble, VLT, Subaru, JWST, TESS. The best gear humanity has will be pointed at it. Because after this, it's gone. Past Jupiter. As sunlight hits the surface, the exotic ices, sometimes surface carbon oxide and dioxide, don't melt. They sublimate. They jump straight from solid to gas, dragging dust with them and inflating that enormous glowing shroud around the nucleus. The SphereX mission measured it back in mid-August 2025. Size, chemistry, composition, all textbook, all public, all perfectly safe if you believe the press releases. But the official narrative is always the same. It's normal, it's fine, move along. They point to fuzzy telescope images, blurry Mars orbiter snapshots, and spectra filled with carbon. Too far, too dim, too fast, they say. That's the script. Every time someone asks why the pictures never get better, the answer is a wall of technical jargon. Pixel scales, exposure times, atmospheric limits. Convenient, isn't it? Because when everything stays fuzzy, nobody can challenge the story. The coma? Just an instrument limit. The jets? Wrong angle. Any anomaly can be explained away if the picture is blurry enough. But the real trouble started when spectrometers finally got a clean look at 3I/Atlas. And what they found shouldn't exist. Water makes up 4% of its outgassing. 4%. Normal comets, even weird ones, carry 10 times that amount. Yet this object is blasting gas and dust like it's got oceans inside it while running almost bone dry. So what's powering it? Carbon dioxide, exotic ices, strange volatiles, and then the real shock. Metals, nickel and iron, industrial levels of nickel and iron, showing up in ratios you expect from engineered alloys, not from a rock that's drifted through interstellar space for billions of years. Researchers rechecked calibrations, then checked again. Same result. But the official line? Dark comet. Case closed. Don't ask questions. Except the chemistry refuses to fit the box. Water missing. Metals everywhere. A chemical fingerprint unlike anything we've cataloged. This isn't a dirty snowball. This is something else entirely. And then came perihelion. That changed everything. Astronomers expected a little brightening, maybe a bump in activity. Instead, the comet exploded into overdrive. Hubble measured 6 kg of fine dust per second and 60 kg/s in larger grains. Those numbers are not typos. That is a sandblaster in space. But the direction of the plume stunned everyone. It wasn't streaming away from the sun. It was firing toward it. A sunward jet. It only happens when exotic ices flash heat and detonate off the surface in violent bursts. And then the color shifted. At perihelion, 3I/Atlas turned bluer than the sun, not metaphorically, measurably. Higher energy, higher ionization, a spike in activity that no textbook comet model can comfortably explain. The light curves didn't rise gradually. They jumped, like the object was responding to the sun in sudden bursts, then settling, then bursting again. Tests and ground observatories confirmed the spikes. All real, all logged. A hyperactive object with impossible chemistry. A comet behaving like it has instructions. And that's not even the strangest part. When astronomers traced its trajectory backward, the projected path passed within 9 degrees of the source of the 1977 WOW signal, the 72-second narrowband radio burst from deep space that's never repeated, never been explained, and never been forgotten. 9 degrees. In cosmic terms, that's a dart hitting the board. Nobody's saying 3I/Atlas sent the WOW signal, but the timing, the geometry, the coincidence, it's uncomfortable, especially when you consider what comes next. March 16th, 2026. Every mission planner has that date circled. On that day, 3I/Atlas will pass Jupiter at 53.4 million. Jupiter's Hill sphere, the edge where its gravity takes command, is 53.5 million K. That is threading a cosmic needle. Most comets miss by tens of millions of kilometers. Even spacecraft need years of calculations to fly that close without being captured. Yet here's an interstellar object on a hyperbolic orbit, skimming the boundary of Jupiter's gravitational reach with surgical precision, almost like it knew where the line was. Avi Loeb didn't dance around it. He called the pass an extraordinary coincidence, the kind of alignment you expect from a mission profile. Because if you wanted to drop a probe into Jupiter's gravitational well without burning fuel, this is the corridor you'd choose, and the numbers match, down to a fraction of a percent. Then we get our moment. December 19th, 2025. Its closest approach to Earth. Every major observatory is preparing. Hubble, VLT, Subaru, JWST, TESS. The best gear humanity has will be pointed at it. Because after this, it's gone. Past Jupiter,